Alright, so let's pick up where we left off. Excuse me. Continuing in lesson 6.1 in our work with rational expressions. We just talked about how to multiply rational expressions together. And when we say multiply, we really mean squish them together as one fraction, factor, and then reduce. And write your answer in completely reduced form. So we're going to take that idea and continue working, but now we are going to talk about dividing. So now if I had to divide fractions, I'm still going to be going ahead and simplifying rational expressions. Oh, let's just ignore that right there. Okay, so let's see how we go ahead and do that. So similar to the way we worked with it before, we have a fraction a divided by b and another fraction c divided by d. And so if I wanted to do a over b divided by c over d, well, in actuality, what we end up doing is we take this division sign and turning it into a multiplication sign. And the reason we get to do that is because now we're going to take our fraction c over d and flip it over. So instead of dividing by a fraction, we can actually end up multiplying by its reciprocal. Notice that our first fraction, a over b, doesn't change. And the reason behind this is a over b, if I write my fraction like this, my division, a over b divided by c over d, in essence what I'm trying to do is I'm trying to get my denominator equal to 1. So I can do that by multiplying by d over c. And so you can see c times d, d times c, that's going to give me equal to 1 over there. But I can't just multiply a fraction by the denominator. I have to multiply it to the numerator as well. So I'm going to take this d over c, which ultimately is just 1, and see what that equals. Well, c over c reduces, d over d reduces, that gives me 1. And on the top, I end up with a over b times d over c, and that's exactly the same as what our original was. So that's the reasoning behind why dividing by a fraction is the same as multiplying by the reciprocal. So in other words, instead of saying dividing by a fraction, we can use the phrase multiply by its reciprocal. And let's put that into practice right away. So you can see here I have this trinomial over another trinomial divided by y plus 2 over y plus 3. So instead of thinking it as dividing by this fraction, I can take my original y squared plus 4y plus 4. Again, the original fraction doesn't change. This is going to stay exactly the same. But now this division is going to become multiplication. Whoa, let's put that back. It's going to become multiplication. So times, and then the fraction, the second fraction over here, is going to end up being reciprocated. So the y plus 3 is now going to be on top, and the y plus 2 is going to be on the bottom. And now, this problem is just like the previous problems where the directions were to multiply. Instead of multiplying, we're actually going to just go ahead and write it as a single fraction. So this is equal to, and I hope you don't mind, I'm going to combine steps. I'm going to factor that. So that's y plus 2, and then I still have this y plus 3 there. And then down here on the bottom, I'm going to actually factor that as well. That's y plus 3, and then I still have that y plus 2 from the original. So notice the blue ones didn't change at all. Now I can reduce. So the y plus 2 and the y plus 2 reduces, this y plus 3 and this y plus 3 reduce, and ultimately I'm left with a final answer of y plus 2 divided by y plus 3. And that's how I leave it. So there's my final answer for this division problem. What do you say we get another example? So let's just use it without any variables, just normal integers. So 3 divided by 5 divided by 6 divided by 10. So 3/5, instead of division, it's multiply, but now that I've changed it to multiplying, I need the reciprocal of 6 over 10, which is 10 over 6. Now this is going to equal 3 times 10 over 5 times 6, and and we can do a little reducing. 3 and 6 reduces to 1 over 2. 10 and 5, let's see, 5 goes into 10 twice, 5 goes into 5 once, and I end up with 1 times 2 over 1 times 2, which is equal to 1. Aha! How about that? Another way you could have seen this is 6 divided by 10 reduces to 3 over 5 to begin with. 3/5 divided by 3/5. Back up. 3/5 divided by 3/5. We know any number divided by itself is equal to 1, so we maybe can see it a little bit easier. 3/5 divided by 3/5. Any number divided by itself is equal to 1, and so that confirms it. Let's go ahead and have you try this next example here. Remember, first step you should do is, instead of dividing by a fraction, change it to multiplying by the reciprocal. Then write it as a single fraction, then factor, then reduce. I'll meet you back here. Put it on pause now. Never mind that little glitch. Here's what I think the final answer should be. 2ab times the quantity a plus b divided by a minus b. You can see my work here shows kept the original fraction the same, changed division to multiplication, changed the second fraction to its reciprocal. Now I decided to factor the difference of two squares, a plus b, a minus b. I kept this as 2a squared b squared. I kept the ab as ab, and I factored this as a perfect square, a minus b times a minus b. And then you can see I reduced the a minus b with the a minus b. I reduced this a with one of the a's over here, and this b with one of the b's over there, and that left me on top with a 2, an a b, and an a plus b, and on the bottom with only an a minus b. You can see here is your in-class assignment that we'll be working on tomorrow in class. If you want to go ahead and get a head start on it, by all means be my guest, but otherwise this is what class time tomorrow will be relegated for. Please come with any questions and I'll be sure to check in your notes. Alright, hope that wasn't too bad. We'll see you in class tomorrow.